Hey everyone, welcome back. In today's video we're going to continue talking about algebra, but today we're going to start getting into the math. It's only going to be sort of the basics in this one, and then we'll start tackling some more complicated problems in the next video. But so basically last video we started talking about what sets algebra apart from the math that we've been doing so far. So far we've just been working with numbers and doing different things with them. Now we've started using letters or variables to represent unknown quantities. There are other reasons why we'll use letters sometimes. Sometimes it's out of laziness, sometimes it's out of convenience. But there are sometimes that we'll use letters where they do represent a number or a quantity that we actually know, and it just has a special meaning. Like for example, pi. It's a number that we know to a lot of decimal places, but because it's got such significance, we gave it its own symbol. So there are some times that you'll use a letter, sometimes it'll be a letter from the Latin alphabet, like the script that we use, sometimes it'll be something like a Greek letter that represents a number that we know, and other times we'll use a letter, usually x, to represent an unknown quantity, so a number that we don't know. So what we're going to be talking about in this video is basically working with a single variable, so working with one variable. There are problems that will involve more variables that we'll get to later on in this unit, but for now we're going to stick to working with one variable. So the thing that you need to keep in mind is really the only thing that you need to keep in mind is that the rules that we've applied to our numbers from before, in general, those same rules will apply to our variables as well. So they're not really that different. They are still representing numbers. There's nothing, there's no real reason to be afraid of variables just because they look a little bit different from before. There are different ways that we'll write things down when we're using variables. For instance, we saw last time out that we write multiplication a little bit differently when we're using variables, but in general it's kind of the same idea as when we're working with just numbers. So for example, if you had an addition problem, so basically we'll just be talking about working with basic operations with a single variable. So for something like 12 plus x is equal to 17. Now remember, we use a little bit of a fancy x. Some people try to make it more symmetrical, kind of like that. When I'm writing it down, usually it looks a little bit more like this, but on the board, if I try to write it quickly like that, sometimes they won't be connected in the middle, and it already looks weird enough as a symbol that it doesn't need to look like a backwards C and a C or anything like that, so it might look a little bit more like this when I'm writing it out on the board. But just know that that's an x. It's a bit of a fancy x, just to sort of distinguish it from a multiplication sign. And yeah, so here this x really just represents an unknown quantity. So this could be like, I don't know, you went to the store and you bought 17 fruits, and I asked you to go and buy 12 apples, and you also bought a few oranges. And now maybe you don't tell me how many oranges you bought. I know you bought 12 apples because I asked you to, and you came back with 17 fruits in total. So how many oranges did you buy? Now obviously it's not that hard to figure out how many oranges you bought, but that is the unknown quantity that we want to solve for, right? Sometimes you'll have an addition problem where the unknown quantity is the answer, right? So we used to write out addition problems where it would be like 3 plus 5 equals, and then we would just not write anything until we figured out the final answer. But that could be your unknown quantity. You've got 3 apples, 5 oranges, x is your unknown quantity of, how many fruits did you buy in total. So you can have your x over here being added to other things, or you could have the x by itself on that side of the equation. And it's the same idea as with when we write out these equations using normal numbers. I could have had the x over here, and it doesn't really make a difference, right? And same thing over here. I could have had 17 equals this and it's not going to change anything. I can write that however I wish. I could have made this x plus 12, 12 plus x. Doesn't make a difference for addition. Like this order here doesn't make a difference for addition or multiplication, and this thing with the placement of the equal sign shouldn't make a difference for any of them, as long as you are writing it down properly. We're going to come back to these problems in a sec and talk about how to solve them. Now they are simple problems for now, but we will come back and talk about how to solve these. Now similarly with subtraction, you could have had something like 16 minus x equals 15, right? Again, it's not a hard problem to solve. The idea is just that your unknown quantity can be really anywhere. It could have been 16 minus x is 15. I could have done x minus 12 is equal to 2, or I could have done something like 5 plus 8 equals x. These are all different examples, not connected to one another in any way. These are all separate examples of where you could have that x. So it could be the thing that you're starting with, it could be the thing that you're subtracting away from it, or it could be the actual answer. So we've got those three different placements of the variable x. Alright, so sometimes it'll just have one correct answer, and obviously in these examples with the addition and subtraction, there's only one right answer. But you know, you will have some questions, and we'll see them in later units, where you can have multiple correct answers for a given equation. So addition and subtraction, not that complicated. With multiplication, let's say we had 3 multiplied by x is equal to 9. So what we're used to doing is we would put 3 times and then our second number. Now the problem here is that we tend to use x as our unknown variable, or as our unknown quantity. So you don't have to use x, you could use something else. If you're doing a multiplication problem, you could use something else all the time. Like, for example, for me in my physics classes, we have, there are some problems that, you know, if they're focusing on time, let's say, if we're focusing on the passage of time for a given question, then we wouldn't use x as our unknown quantity. If we were trying to figure out how long something took, our unknown quantity would probably be represented by t for time, right? And it can vary depending on what you need it to be. For things in physics, as we were talking in the last video, you know, you could have your unknown quantity for energy could be E, mass could be m, time could be t. There are different options. You don't have to stick to a single letter and use that for every single question. The only thing you got to be sure of is that you're consistent. If you're using t at the start of the question, you can't change it to m in the same question. Keep calling it t, and if you change the name of it, change the meaning of it. Don't let t and m both equal the exact same thing. Like if I'm doing 3 times t equals 9, and then in the next line I say 3 times m equals 9, unless that m represents something else that happens to have the same answer, don't just change the name. Yeah, so you can use any letter that you want. It doesn't have to be like a logical choice. Like if you're talking apples and oranges, you could use an A and an O. But maybe for oranges, you know, using an O looks like a 0, so maybe that's not the best option. But for apples, you could use A, no problem. Or you could do apples and bananas, use A and B, things like that. Feel free to use a variable that makes sense to you. Just make sure that you're careful if you're using things like the same way that we use a little bit of a fancy x. If we're using a small l, if we're using a lowercase l, we tend to write it as like L with a loop, like a cursive L, because a lowercase l looks like a number 1. Now, for me, I write my number 1s like this and my capital I's like that. So to make that distinction, I'll specially put in those 2 lines on my I's if I'm using an I in an equation, so that I don't get it confused with a 1 or with something else. But the one thing that you really need to be careful of when you're working with a problem like this, I'm going to revert this back to an x, is especially if you're using x and you're doing a multiplication problem, this can get a little bit confusing. So you have 2 options, and you will tend to see both of these options if you're, you know, like flipping through a math textbook or something. You'll tend to see both options pop up when you start working with letters in your equations. Your first option is to get rid of the multiplication sign and just write it as 3 x equals 9. That's one option. So when you have a number and a variable stuck together with nothing in between them, that indicates multiplication. All right, so this thing in here with these two being joined together indicates that you are multiplying. All right, so that's the one option. The other option is to replace the x with a dot. So you could rewrite it as the same thing that we started with, but instead of a multiplication sign, put a dot that's not like a period, but like a little bit higher, sort of in the middle of the top and bottom of the line that you're writing on. So don't put it all the way at the bottom, because that would look like a decimal point or a full stop. But it'll be 3 times x, like that. That's another option. So you could write it in any of these ways. This top one, I strongly advise that you don't use this method, just because we use x so frequently in algebra that having x also be the multiplication sign, even though it looks a little bit different, can get really confusing really fast. Even if you thought you understood the line, when you're going quickly through a problem, you might see, oh, 3xx, that means x times x, and you start to confuse yourself with having two slightly different x's. So try not to use this one. Try to use one of these two if you're doing a multiplication problem. I feel like I had one more thing that I wanted to bring up about multiplication. Oh, right, one other thing. So for using this notation, we're using a dot for multiplication. What I find is if you're working with just numbers, so like if you're in this question, x would have been equal to 3, right? Because 3 times 3 is equal to 9. If you're working with just numbers, feel free to use the x there to represent multiplication. But if you're working with just numbers and there are no variables in there whatsoever, I would sort of refrain from using the dot as multiplication, because so I would try not to use the dot, because if you write it in slightly slightly off center and write it a little bit down here, now it looks like 3.3 instead of 3 times 3. So if you're working with numbers, use the x. If you're working with numbers and letters, you could use the dot, or you could just play it safe. And if you're working with numbers and letters being multiplied together, don't even put anything, just stick the two things together. The other way that you can see multiplication written, and I might do this sometimes, and you'll have seen this a little bit, is that you could do 3 in brackets times x in brackets equals 9. So this set of brackets contains a 3, this set of brackets contains an x, and the two sets of brackets have no operation in the middle, so that means multiplication again. So those are the sort of different ways that you could see multiplication written out in a solution to a problem. Alright, so that's covered, I think, everything that I wanted to say about multiplication before we go ahead and actually try and solve these. But now let's just talk quickly about division. So for division, you could have something like this. You could have 7 divided by x equals 1. Now for the multiplication problem, I should clarify, again, you can have that variable wherever you want. It could be the first thing that you're multiplying, the second thing, or your final answer, and for multiplication that order doesn't matter. For division, the order here does matter, so you could have it as your divisor, you could have it as your dividend. You could have something like this instead. So you could have it as your dividend, you could have it as your divisor, you could have it as your quotient, so it could be your final answer there as well. So you could have something like this. So you can have that variable go wherever it needs to go for that problem. The one thing I wanted to point out for division is that, let's get rid of this. The one thing I wanted to point out for division is that if you have something like this, you might see it written out without the division sign, and you'll see it written as a fraction. So you'll see it written as 7 over x is equal to 1. And I know you guys have seen this before, but I just wanted to point it out because it's one of those things that like for me in my university courses and stuff, I never ever write this division sign anymore. Anytime something is being divided, it's always written as a fraction. So it's just one thing to be watchful of if you're doing math at like a university level in a few years' time. This sign tends to sort of just drop off the face of the earth, and everything starts to be written in this way. Now, obviously, that might not be the same thing everywhere. That could just be a me thing, could be a my university thing, but this seems to be sort of the norm among my classes and my professors and stuff, and they've come from all over the world. So, just a word of warning: you might see me do this sort of instinctively now, but also if you're looking through textbooks that are basically anywhere above the sort of the intro level to algebra, they might just do away with the division sign as well and start writing everything in this format. But other than that, it's sort of with multiplication and division, there's a little bit of that housekeeping stuff of, notation differences and just things to watch out for there. But the rules for the math are exactly the same. Now the difference here is that because we can put the variable wherever, I can set up the question and give you the answer and ask you to find something else. So you have to do a little bit of work with the numbers that I've given you to actually solve the question. So let me show you what I mean. If we were doing an addition problem, one of the examples I wrote down was 3 plus 5 equals x, right? Now, when you're first learning math and you're learning counting and addition, like at the hummingbirds level, then you are basically doing this type of problem, except the only difference is they would write it as 3 plus 5 equals, and then they just leave it blank until they figure out what 3 plus 5 actually is. And they'll eventually get 3 plus 5 is equal to 8, and that's a terrible 8, but they'll finally get their answer, and they'll throw it in there, and that's it. That's the end of the problem. They don't need to write down anything special. They don't need to say x equals blah, blah, blah. They're not working with letters at all. So you could get a question like this where you don't need to rearrange stuff or anything like that. But basically the goal is if you are trying to solve whoops, there goes my cap for my marker, but that's not a problem right now. Basically, what was I saying? I lost my train of thought. Yeah, so basically when you're trying to solve one of these equations, it's not necessarily about getting the answer the way we tend to write these questions out, right? Like normally when we write out a question, whether it's addition, subtraction, multiplication, division, the answer is the thing that goes over there. We have to figure out what it is and put it in that spot, and it's almost always written like this. You'll have the information that you're given equals blank, and you have to fill in the answer there. Sometimes I'll give you the answer, and the thing that you don't know is something over here. So you have to do a little bit of fiddling around with it before you can get your final answer. Now, if I've written it as 3 plus 5 equals x, and you just go on your paper and you write down 8, that's right, but that's not really connected to the question. The most proper way to do it would be to say x is equal to 8. So if you're working with algebra and you're working with variables, try and remember to keep the variable actually in your final answer. If the variable is what you're solving for, you should say this variable x is equal to, and then whatever it's actually equal to. Later on in this unit, we'll talk about working with more than one variable, and so if you're trying to work with like x and y, then we'll have a little bit of a problem if you're just writing down one of the answers for one of the variables without telling us which one, and then you go ahead and write down the answer for the other one. Maybe you had them backwards, maybe you have them right and we interpret them backwards, but it's important to say which variable you found the answer for. And it's just a good habit to sort of have to, even with one variable, to just say x is equal to whatever. So just try and keep that in mind. But now we'll get to a more interesting case, even though it's addition and it's a simple question. If you have something like the first example that I wrote up, so 12 plus x is equal to 17. So if you have something like this, now the answer to the question, the answer the way we would write, like the place that we would write the answer in normally for an addition question would be this 17, right? That would normally be our answer. But because we're trying to solve for x, that's usually when you have these algebra problems, you're trying to solve for the variable right here. So we want to find what this unknown quantity must equal in order for this equation to be true. That if you had 12 apples and you bought X oranges, how many oranges must you have bought in order for there to be 17 fruits in total? So you know there are 17 fruits, you know 12 of them are apples. What must be the number of oranges that makes this equation true? So that makes it true that yes, you got 12 apples, and yes, you got 17 fruits. If those are assumed to be true, what must this quantity be? Now, the way to solve it is, it's a similar pattern for all four of these basic operations. And it's a simple pattern, and it's a similar pattern for even things like exponents and stuff, is basically you want to do the opposite operation. If you have like this x, so in this particular question we've got this x stuck being added to 12 on this side of the equation. So we don't have x equals 17, we have x when you add it to 12, or when you add 12 to it, is equal to 17. But I don't want x plus 12 or 12 plus x, I want just x is equal to, the number of oranges. So in order for me to get rid of the 12 on this side, I'm going to rewrite the left side that I have here. So it's 12 plus x, and I'm going to leave a little bit of a gap, is equal to 17. Now, I don't want 12 plus x, I want just x. So since 12 is being added to this x, in order to get rid of the 12, I'm going to subtract 12. Alright, so I've got 12 plus x minus 12, right? But this thing, I just threw in there right now. I just threw in a minus 12, which is changing the question. I'm not allowed to just throw in plus or minus 12 or 10 or whatever. I can't just throw in whatever numbers I want and whatever operations I want to go with them. I have to, if I'm subtracting something from the left side, I also need to subtract the same thing from the right side. So if I've subtracted 12 from here, I need to also subtract 12 from there. So now what we have here is x is the number of oranges plus, let's say, 12 apples minus 12 apples. So this 12 and that 12 disappear, right? Because this is a positive 12, that's a negative 12. Those two cancel each other out. And so on this side, I'm left with just x. And on that side, I get 17 minus 12 is equal to 5. And so that would be one way to solve this type of question. Now there's a little bit of a difference in the way that you could go about solving this type of question, so I'm going to show you another way. This is the way that I learned it in school, but this isn't the way that I learned it initially. Initially I learned it from my parents, who explained it. They might have explained it this way, like as sort of like a reasoning for it, but in terms of the way I think about how to actually solve this, I think about it differently. The way I think about it is, if I want this x to be by itself, then I don't want the 12 to be on the same side of the equation. Basically, if you've got a whole bunch of variables, even if they're all x's, so it could have been like 2x minus x plus 12 plus x equals 17. So you could have had a whole bunch of x's over here. The basic rule is, get all the things that involve x's over on this side of the equation, and all the numbers on that side of the equation, or vice versa. Just make sure all the variables are on one side and all the numbers are on the other. One more point is, if you've got something like 12 plus x, that does not equal 12x. You can't add numbers and letters just like that. If I had 2x plus x, that would be 3x. Basically, try and replace the letter x with some sort of object. If you have 2 apples and then you add another apple to it, you have 3 apples. So that's sort of the way the x's work. Think of it as an object that you can add to it. A lot of people, when they first get introduced to this concept, they'll think, 12 plus x is equal to 12x, or they'll think that 2x plus x is equal to like 2x squared or something. And it's just, they end up mixing up their addition and their multiplication or things like that. So try not to make those mistakes. You can't add and subtract numbers and letters unless you get more information. And same with multiplication and division. With multiplication and division, it's a little bit different, right? If you have 3 times x, you can write that as 3x. But just be careful when you're working with numbers and letters, because it can get a little bit confusing, and sometimes you'll slip up and put things together when they shouldn't be together. So anyway, back to this task at hand. To actually solve this question, the way I learned to do it is that I want this x to be by itself. That's a terrible x. I want this x to be by itself on one side of the equal sign. So I'll put the x here. Now I take this 12 and I chuck it over there on the end of the other side. So I take this 12 and I chuck it all the way over there on the end of the other side of the equal sign. So instead of having 12 plus x over here, I've got 17. I'm throwing the 12 all the way over there, and I'm just going to do the opposite operation of what I was doing here. So if I was, in this case, we're adding here, so when I throw it over there, I'm going to subtract. And so that's going to give me x is equal to 17 minus 12 is 5, so I'm going to get that same answer of 5. This works for all of them. So if you had, I'll show you another one. I'm going to get rid of this one now. We'll go back to one of the subtraction ones. Basically, in order to get the variables by themselves, if they're being multiplied to a number, take that number over to the other side, and instead of multiplying, divide. If you're subtracting a number from x, take the number over to the other side and add. So do the opposite operation. If you were initially adding, subtract. If you were initially multiplying, divide, and so on. So if we go back to our subtraction question and we do something like 16 minus x is equal to 15, now I don't want 16 minus x over here. So I've got two options. I could take the 16 and throw it over there, but that's going to leave the minus sign stuck with this x. This is a negative x over here. So I could do it as negative x is equal to 15. I'm going to throw the 16 all the way over to the other side. And this 16, even though this is a subtraction problem, the 16 itself is a positive 16. So when I throw it over to the other side, I need to make that minus 16. This is where this can be a little bit confusing. This is a positive 16 over here. Even though it's a subtraction problem, this is the positive number, and the x is the thing that has to keep the negative with it. So it's positive 16 minus x. Or you could think of that also as positive 16 plus negative x. So that's why the negative sign has to stick to this x, and then when you throw the 16 over on the other side, it goes from being positive to negative. And so you could go about solving it this way. You could throw the 16 over to the other side, or the other way you could think about it, we'll do it all the ways that we could think about it. So that we would get negative x here, and then 15 minus 16 is going to be negative 1. These negative signs will cancel each other out. Basically you're dividing by negative 1 or multiplying by negative 1, and you would be left with x is equal to 1, which is pretty clear from what we started with. 16 minus what number equals 15? It's going to be 1. It's got to be 1, right? A couple other ways you could solve this. One is to, instead of throwing the 16 over and changing the operation, one is to do 16 minus x, and then I'm going to leave a little bit of a space and put a 15 over there. And right now we've got a positive 16 over here, so I'm going to subtract 16 from this side and subtract 16 from that side. So the only difference is really instead of ignoring all of the 16s from one side of the equation and throwing it on the other side, I leave all the 16s that I started with, which in this case is just that one, but then I write in the thing I'm subtracting in two places. So I'm sort of thinking about it in a different way. I want to subtract 16 here, but if I do that to this side, I also have to do it to that side. So then I'm going to have this 16 minus that 16, so these will disappear. That's going to leave me with just negative x on this side. Remember, this negative stays with the x, so it's negative x is equal to 15 minus 16 is negative 1, which will give us the same thing that we were getting before of x is equal to 1. The last way that you could think about this, I hope I'm not going too fast, but the last way that you could think about this is you don't have to be adding or subtracting the numbers. You could add or subtract x's. Right now, x is the thing that's being subtracted, so what if I added x to both sides? So if I wrote this out slightly differently, you can add x to both sides, so it'll be 16 minus x plus x is equal to, now we started with 16 minus x on the left side. So this part is what we started with. We've added on this plus x over here. So on the other side, it should be 15, and then whatever I've done to the left side, I have to do to the right side as well. So it'll be 15 plus x, like that. Now here I've got 16 minus x plus x. Those two will cancel each other out. That's taking away something and then putting it right back. So I get 16 is equal to 15 plus x, and then sort of we go in reverse. I don't want the 15 over there, so I'm going to subtract 15 from that side, and I'm going to subtract 15 from that side, and it's going to leave me with 1 is equal to, well, this 15 will go because we've got that 15 over there, and we'll be left with x. So there's a whole bunch of ways that you can go about this. I'm sort of speeding through this because I know you guys have seen some of this last year. But we're going to end up doing a whole bunch more problems on this stuff in the next video as well. So don't worry too much about it if this is a little bit fast right now. Basically, the idea is the number that you're dealing with, the variable that you're trying to solve for. If there's another number that you have to deal with, throw it onto the other side and do the opposite operation. The only thing you have to be careful of is that if it was being added on this side, when you're subtracting it on that side, make sure you put the number in the right spot, because 15 minus 16 and 16 minus 15 would give two different answers. They would differ by a negative sign, right? So those are the things that you got to be watchful of. I'll just quickly zip through the multiplication and division, and then we'll call it a day. So the multiplication problem, it was not an overly complicated one. It was 3x is equal to 9. So again, two ways you could think about this. If I just divide the board up, we've got two ways to think about it. One way is I take this 3 and I chuck it over onto the other side. So I'm left with just an x over here. But I was multiplying by 3 on this side, so I should be dividing by 3 when I throw it over there. Right now it's being multiplied. When I throw it over to the other side of the equal sign, I'm going to flip the operation. So it'll be 9 divided by 3. Or if you wish, you could write that as 9 over 3 if you want to get used to using of fractions to denote division. Again, you have to be careful that you do 9 divided by 3 and not 3 divided by 9. You have to be watchful of that order. So whatever information you already have on the other side, keep that in the front, and then if you're dividing or subtracting something, throw it all the way at the end. That's why when we were first doing the first example, I threw it all the way over there, so that sort of shows you an operation needs to go in here, and it's going to be division, but this just is to highlight that it's 9 divided by 3 and not 3 divided by 9. So just be careful of that, and then obviously 9 divided by 3 is equal to 3, so you'll get x is equal to 3. The other way you can think about it is, it'll get you the same answer. The other way you can think about it though is that we've got 3x is equal to 9, but I don't want 3x, I want just 1x. I don't want 3 times the number of apples, I want just the number of apples. So to get rid of this 3, I'm going to divide by 3 on this side, but if I'm dividing by 3 on this side, I also need to divide by 3 on that side. So if I divide by 3 over here, this 3 disappears, this 3 disappears. It's basically reducing fractions, and we're left with just x over here, is equal to 9 divided by 3 is equal to 3. So again, it'll get you the exact same answer, but it's just a slightly different way to think about it. But yeah, hopefully that's making sense. So that's an example of multiplication. Once again, I know I'm going a little bit quick right now. I just don't want this to be too long, because after all, these are still simpler problems, and I want us to have plenty of time to get through the harder problems without having to rush through those. So if you are finding that this is a little bit fast, then try to go back and rewatch it, but I'm going to try and slow the next one down to make sure that we're really getting this. So the last one we did was a division example. So we had 7 divided by x is equal to 1. Now I don't want x's in the denominator. So what I'm going to do is, again, you can think of this in two ways. I can take this x and throw it onto the other side and flip the operation. So right now it's being divided. So then when I throw it onto the other side, it'll be multiplied. So it'll be 7 is equal to 1 times x. Now 1 times x is just going to be x, so I don't even need to write in that 1. I'll write that in the second line. So that's the same as 7 is equal to x, and well, in this case, that is our answer. X is equal to 7. 7 is equal to x, same thing. And that's it. You just take this x, throw it over to that side, and flip the operation. So over here it was being divided, so when we throw it over there, it's being multiplied. This is 1 times x, which is equal to x, and we get x is equal to 7. The other way you can think about it is, it's a little bit longer in this case, but you had 7 over x is equal to 1. I don't want an x in the denominator, so I'm going to multiply by x to get rid of all the x's from this side, because then these will cancel out, right? It's 7 divided by x multiplied by x. I've done opposite operations, so they'll disappear. But if I'm multiplying by x on this side, I also need to multiply by x on that side. So then on this side, this x will disappear, that x will disappear, I'll be left with just 7. And then on the other side, 1 times x is equal to x. And again, we get the same answer that we got the first time, which is x equals 7. Alright, so basically the gist of it is do the opposite operation when you're trying to get a variable by itself. When it's attached to a whole bunch of other numbers, you have to get rid of all the numbers that it's attached to, and basically the easiest way to do that is sort of do the order of operations, that bedmass stuff, but backwards. So things that are being added and subtracted, deal with those first, then deal with things that are being multiplied and divided, deal with those next, and then deal with exponents and then brackets. We'll get to those more complicated examples a little bit later on, so you can see exactly what we're talking about. We'll end up dealing with more complicated questions that have more x's, and then eventually we'll end up dealing with questions that have more than one variable, so like an x and a y. And we'll talk about all of that stuff in the near future, but at the time of recording, right now it's 9:53 p.m. This video is already 37 minutes long, and I don't want to make it any longer for you guys, so we are going to call it a day, and we will resume with more of these practice problems in the next video. As always, if you guys have any questions, feel free to reach out to me. Otherwise, I will see you next time. Have a good one.